Okay, let's talk about this warm-up. Okay. Kane, what did you get when you plugged 2 in for X? When you plug 2 in for X? So Y equals -4. Okay. Okay, so what did you get? Y equals what? I'm asking Kane, Abby. Okay, what'd you get? Okay, Y equals -1. Okay. Now I would highly suggest that when you substitute in for a number, you substitute using parentheses. So this -4 times 2, put the 2 in parentheses, because when we go to do this, when X equals -3, Y equals -4 times -3. Ooh, am I subtracting? Am I timesing? I don't know. But if it's in parentheses, there's no like, I don't know. It's obviously multiplication. Okay. When we plug -3 in for X, okay, Peyton, what do we get? Do you agree? -5.
No.
Peyton, what's -4 times -3?
Oh, +5.
What's a positive 12 plus 7?
19.
Because 12 plus 7 is 19, right? Yeah. Okay, are we good with that? Okay. Level of, what'd you say? Oh, it's a Monday. It's a very Monday-ish Monday. Okay, now thumbs up, thumbs middle, thumbs down. You feel about plugging a number in for X. Plugging a number in for X. You are telling me that you can plug a number in for X. Okay, guess what? That's all we're doing today.
Yay!
But it's going to look a little different, because we need to talk about function notation. Okay? Let me be clear. Let me be clear. What you just did is exactly what we're going to be doing. It is only going to look different with the notation. Okay? So you've all, Colin, this is like the 3rd time I've tried to get your attention. Just stop. Put your glasses on the right way and pay attention. The only thing different is our notation's just going to look a little different. That's what we're going to get used to today and tomorrow. Okay. So let's do it. Okay. Go ahead and turn in your journals to page 71. '71. Okay, I'm waiting for you to be quiet and you to have this page open. 71. Okay, so here's our new notation. Are you ready? This is our notation, and we say f of x. F is the most common name we will give a function. It's not the only one. X is the most common input we will use, but it's not the only one. Okay. F of x is an output Thank you. Okay, f of x is replacing y. Okay, f of x is the same thing as y. Okay, so when you see an f of x, it's just representing an output. It's the same thing as a y. We're just calling it f of x. Okay, I need you to understand that these parentheses do not mean multiplication. Okay, they're more just signifying what the input is. Okay, so this f of x, my input is inside that notation. Okay. Okay, so we just talked about the equation y equals negative 4x plus 7. Okay, we are going to change it to a function. So instead of y equals negative 4x plus 7, we are going to write it as f of x equals negative 4x plus 7. Okay. That notation is just representing the output for whatever input we have right there. Okay. Now, in our warm up, I asked you to plug in 2. You remember that? Okay. So when I want you to plug in 2, then I'm going to do this. Find f of 2. Okay. Really, that just means find output x equals 2. Okay, now I'm going to build a function machine. Okay. Are you ready? Okay. So this is what happens when we have a function. We have an input, we put it into the machine, and it gives us an output. Now the machine is just the equation, guys. It's exactly what we did in our warm-up. Okay. So for this example, we are going to put in x equals 2 to the equation negative 4x plus 7, and we're going to get an output. Okay. In our warm-up, what did we get? -1. Okay, we got -1. Okay, now you're probably not going to draw this weird little like machine thing for me. Okay, but I want you to understand what's happening. Okay, we're taking x equals 2, we're plugging it into the equation, and we're getting an output. This is probably the work that you're going to show me. Okay, if f of x is negative 4x plus 7. Okay, all I did is I just rewrote our equation. Okay, I'm asking you for f of 2. So do you see how I changed my input from x to 2? Okay, the input was x here. Now it is 2. So anywhere there's an x, I'm changing it to be a 2. Negative 4x plus 7. Well, instead of x, I'm writing in 2. now what does this mean? This means when X is 2, Y is -1. So if I wanted to graph this, we would have the coordinate 2, -1. Literally the same thing we did in our warm-up. It just looks a lot different. So let's do find f of -3. Well, if f of x is -4x plus 7, and I'm asking you for f of -3, since my function notation, -3 is there instead of x, then in my function, I'm going to replace -3 with x. Let me say that again. I'm going to replace x with -3. So this is -4 x plus 7, but instead of x, I'm going to punch in -3. Twelve plus 7 is 19. Okay. What this means is that on the graph, we have the coordinate -3, 19. When x is -3, y is 19. Am I blowing your mind? No? Okay, good. I have no idea what you just mumbled. That's okay. Let's go to the next page. You have a question? Okay. You have the case of the Mondays. All right, so let's look at number 1 on this next page. Number 1, f of x is -x plus 4. Okay, the first thing that I want us to calculate is it's asking for when x is -4. So I want to know f of -4. Okay, so we're going to plug -4 into the machine. The machine is just our equation, and it's going to give us an output. Okay, now this is what I like to do when I'm plugging numbers into functions. I like to rewrite it, but instead of x, I write a parentheses. So -x plus 4. You see how I did that? Now, instead of x, I'm going to write -4. What is negative times -4?
Negative.
It'd be +4. +4 plus 4. F of -4 is 8. Let's talk about f of 0. So this is like a -1 right here, right? So I have a negative times -4. Negative times a negative makes a positive. So this is +4 plus 4. So like, I need you to imagine that this is like a 1 right here. So it's like -1 times -4. Give us +4.
Would there be like that one like every time?
Just like, because this is like negative x, right? So we kind of view this as negative 1x. We just don't write the 1.
Oh, so the one makes it work. That's why.
Negative times a negative is a positive, yes. Okay, are we good on that? Thank you for asking that question, Reagan. So let's talk about f of 0. F of 0. Okay, well, our function is negative x plus 4, but my input is now going to be 0. So wherever there's an x, I'm going to write a 0. Okay, f of 0 is 4. All right, they also want us to find f of 2. Okay, so we're not going to worry about this guy right here. Okay, so f of 2. Okay, anytime I'm evaluating a function, I'm going to take the equation and I'm going to make the x a parentheses, negative x plus 4. But now I'm going to plug in x equals 2 for that x. Negative 2 plus 4. Good. Because it's a negative.
Oh,
Two.
and the 2's not negative.
Correct.
Okay.
Correct. Okay. All right. So what I'd like you to do is I'd like you to evaluate the function in number 3 with x's negative 4, 0, and 2. Now this time we have h. H is the same as f. It's just the name of the function. Okay, so you're going to find me h of negative 4. You're going to find me h of 0, and you're going to find me h of 2. Make sure you and your elbow partner agree. Yeah, we're skipping number 2, and this is the number 3. Mhm. Yeah. This is boring. Okay, I'm sorry. I'll make it more exciting.
It's fun.
I don't know.
You just like stand there and give kids.
Well, I'll take my kids trick or treating and then hand out candy when we get back. There's still elementary. We have school the next day. Okay.
Not come to school. For like one day. I'm all gonna be so happy.
We're doing this. Okay, eyes up here. Seth, what did you get for h of negative 4? $15. Okay, Kane, you are helping him out. You got 15. If we plug -4 in here, we have 7. This becomes +8, right? Plus 15. Okay. All right, Gavin, what'd you get for h of 0? What about h of 0? Okay, good. So if we plug 0 in for x, we get 7 minus 0, which is 7. Good. Manny, what'd you get for h of 2? Okay, if we plug 2 in for x, we get 7 minus 4, which is 3. Okay, cool. Now, read through number 7 for me.
What?
Just read through it. Read. Just read through number 7's description. Okay, N of T is the number of DVDs, so our output is the number of DVDs. And after T trips, well, do you see how T is in our function? That is our input. Number of trips. Okay, so this N of 0 equals 8. Well, 0 is our input and 8 is our output. So after 0 trips, you have 8 DVDs. 0 is our input, standing for the number of trips. 8 is our output. So basically, you are starting out with 0 DVDs. I mean, 8 DVDs. You haven't gone to the store yet. You have 8 DVDs. Okay.
I'm just wondering, like, if you've never gone to it, how do you have DVDs?
You have some to begin with. Okay. So now let's talk about N of 3 equals 14. Okay. Nirvan, what would that mean? After 3 trips, you have 14 DVDs. Okay. Now this part C, it says N of 5 is bigger than N of 3. How so?
Because you put in your 5 for your equation. So it's not 5 is bigger than 3.
Okay, so what is N of 5 standing for?
5 trips.
Okay, so the number of DVDs after 5 trips is bigger than the number of DVDs after 3 trips. Well, that would make sense, right? So the number of DVDs after 5 trips is greater than the number of DVDs after 3 trips.
I mean, if you're at almost nothing at 13 trips. 'Cause
Yeah. As long as you're not like breaking DVDs, you should be getting more, right? Okay. All right. Now, I want to work backwards a little bit. I want you to look at number 8. Okay. Number 8 is giving us the equation, function, -3x plus 1. And I'm telling you that one of the outputs is -20. I want to know what the input is. Okay. So when I say b of x equals -20, this is an output. Okay. So what are we going to do with -20? Where am I going to put, am I going to put -20 for x? No. Negative 20 is b of x. So I'm going to come over here to the negative 3x plus 1. And this is an output. So I'm going to put it over here where my outputs go. How do I solve for x? What do I do first, Colin?
Minus 1 negative 21.
Okay. So we just figured out that the input of 7 gives us an output of negative 20. Nope, B. This is definitely B. B of 7 gives us an output of negative 20. That's what we solved for. That is what we did. It's okay, hold it. Okay, you try number 9. Okay, so my answer is x equals 7. This is what it means. You try number 9. I disagree with that. Did you forget about the minus 3? Okay, I want to know what the input is that gives us an output of 33. Andrew, what do we need to do to set this up? Okay, this is how Andrew set up his problem. I don't know why you're still talking. Do you agree? Thank you, Peyton. Do you agree with Andrew's setup to the problem? Okay. Avery, what do we move first?
The 4. Or the 3.
Okay, we need to add the 3 first. To get 36 equals 4x. Then we can divide by that 4 to get x equals 9. Okay, the answer I'm looking for is x equals 9 because the input of 9 gives us the output of 33. I feel like this has to lead to something, right? Yeah. You probably just looked at the next page, right, Sophia?
I've never seen you use orange.
Oh, really? Okay, so here's the deal. We are finally moving into our graphing of linear equations, okay? And the first way we're going to do that is to literally just make a table of inputs and outputs, okay? So this, I'm gonna have you help me. Okay, purple table, plug in -4 to s of x. Blue table, plug in -2. Yellow table, plug in 0. Teal table, plug in 2. Red table, plug in 4. And green table, Also put in 4, just to make sure that the red table's right.
It's fine. I don't need.
That part's not important.
Yep.
Because you multiply that by 2.
What? You're plugging it in for X.
Okay.
Yep.
What are we plugging in?
It's negative.
Oh, you're right.
Okay, eyes up here, please. Okay, so we're going back to, these are our inputs. So all of you should have work that looks like this: 1/2 X minus 2. And you're putting your X value right here. So purple table, when we plug an X value of -4 in, what do we get?
-4.
We get an output of -4. When we plug -2 in for X, our output is blue table. Are we okay with that? Okay, we're gonna plug -2 in for X. So 1/2 times -2 is what? What's 1/2 times -2? Oh, I'm asking you. What's 1/2 times -2?
What is 0?
-1 minus 2 gives us our -3. Okay, when we plug in 0 for X, what do we get? Yellow table. We get -2. Teal table, S of 2. And the rest of you, S of 4. Okay. So this is what we're gonna do. We go -4, -4 is a coordinate. -2, -3 is a coordinate. 0, -2. 2, -1, and 4, 0. There is a line. It is so beautiful. Is 2 a straight line? All lines are straights. All lines are, your line, my line's straight.
What about curvy line?
I do. So those of you who may be bothered that your line isn't perfectly straight, you could use a straight edge to connect the dots if you wanted to. Just throwing that out there. Listen to me, please. We don't need to be talking about anything right now. You could use a ruler. You could always grab one of these and use. Okay, they're right in front of you. Let's go ahead and graph number 13 together, and then we'll call it a day. Okay, so I'm gonna do this. T of X equals 1 minus 2X. So I'm gonna go ahead and write a parentheses where my X should be, so we can visually see our inputs and outputs. So if I put -2 as my input, what is our output? One plus 4 is 5. When we plug -1 in for X, we have 1 minus 2 times -1. 1 plus 2. So -1. Now, some of you are remembering that lines have a constant rate of change. Okay, so before we even plug in 0, you know that there is a difference here of down 2. So you better have down 2 for this difference also. Okay. When we plug in 1, 1 minus 2 times 1 is going to give us -1. And when we plug in 2, 1 minus 2 times 2 is going to give us -3. Now I have a question for you. So don't close up your books, because I have a question for you once you get this line graph. Correct for that.
Oh, man.
Man.
Is it that hard?
I have a question. Why do you think they gave you different inputs over here compared to number 13? Raise your hand. Why are the inputs different for this number 12 than they were for number 13?
Just for fun.
Because the numbers are changing as it is.
Yeah, because of this right here, okay? I don't really want to multiply 1/2 times 3 and then try to graph something with a fraction, okay? So they chose these numbers so that we could get integers and not fractions. If you have to choose what numbers to plug in, guess what? You can make those decisions, okay? All right, you all have books.